Alright, today I'm going to go over some examples on how to graph rational functions. I am on this page in your notebook, the notes that we started today. I'm going to continue with this. I'm going to go over numbers 2, 3, 4, and 5 with you today. Now, this paper is already worked out, so I'm going to transfer these problems to graph paper and work them on here. But I'm on this page right here if you're looking at it. Find it in your notebook. Alright, so we're going to graph this rational function number 2. Let me zoom in. Okay. I have y equals 3x plus 6 over x squared plus 4x minus 45. Okay. Alright, the first step in graphing rational functions is you want to locate and determine the horizontal asymptote. So I'm going to go over here and write HA for horizontal asymptote. Okay? You look at your highest degree in the numerator, which is 1. The highest degree in the denominator is 2. The higher degree is in the denominator. Remember, if the higher degree is in the denominator, your horizontal asymptote is y equals 0. Y equals 0. If the higher degree is in the numerator, none. There would not be a horizontal asymptote. Now, after you find the horizontal asymptote, you then locate the points of discontinuity. What makes this function undefined? And that can either be a vertical asymptote or that can be a hole. Okay? So I'm going to factor this function. Okay. If you notice the two values that cannot be going in this function is x equals negative 9 and x equals 5. Neither one of these factors can be crossed out, so there is no hole in this problem. You have two vertical asymptotes. You have one at x equals negative 9 and x equals 5. Okay? Now I'm ready to graph this. I'm going to zoom out a little bit so you can see. Sorry about that. Okay? Let's graph our horizontal asymptote first. Y equals 0. Okay, that is on the x-axis. So I'm going to make a dashed line. Then your two vertical asymptotes. X equals negative 9. Oop, I might not have drawn it further enough. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's right over here. I'm going to draw my x-axis out some more. Okay. Extend my horizontal asymptote. Alright, the other one is x equals 5. Alright, now we're going to graph the hole in just a little. Well, there's no hole, so we don't have to worry about hole. What did I do wrong? It's supposed to be x equals 5. I'm sorry, so let me wipe that out. I got it on x equals negative 5. My bad. Glad we caught that now. Okay, so I'm going to go over here to x equals 5. 1, 2, 3, 4, 5, and draw a vertical asymptote. Now I'd like for you to get your graphing calculator and let's graph this. Let me get mine. You go ahead and graph it. Okay. And remember, the main purpose of us doing this is we want to see what is going on at the horizontal asymptote. Remember that the graph sometimes can cross the horizontal asymptote. It can never cross a vertical. And in fact, if you look at this, you see that there is something going on. It is crossing y equals 0, so you can have that in your mind when you construct the graph. Alright, so now we want to make a table. We're going to put this aside for just a minute. We want to make a table. Remember, you want to pick a value to the left and right of each vertical asymptote and always include 0. So to the left of negative 9 is negative 10, to the right is negative 8. Always include 0. Then to the left of 5 is 4, to the right of it is 6. So I'm going to use my table feature now, second table, and go up to negative 10. Negative 10 is negative 1.6. Negative 8 is 1.38. 0 is negative 0.13. 4 is negative 1.385. And 6 is 1.6. Yes, you should have an error of 5 because that's a point of discontinuity. Alright, so negative 10 and negative 1.6. It's going to get very close to the asymptotes, but do not cross them. And there's your graph. Let's talk about domain and range. Domain, starting from the left. I'm good until I get to what value here? Yes, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got from negative infinity to negative 9. Alright. Union negative 9 to going all the way here. I'm hitting some value. I'm hitting some value till I get to 1, 2, 3, 4, 5. Union 5 to infinity. Range. Start from the bottom. It's hitting somewhere. It's hitting somewhere. And you say, well, Mr. Church, how about 0? It crosses 0, so it's even hitting 0. So that's all real numbers. All real numbers. Alright, let's look at number 3. Y equals x plus 5 over x squared minus 9. Okay? Number 3, y equals x plus 5 over x squared minus 9. First thing I'm going to do is find my HA. Okay? The degree is higher in the denominator, so it's y equals 0. Now I'm going to find my other points of discontinuity, which could be a vertical asymptote or a hole. Okay, I'm going to factor it. It's going to be x plus 5 over x plus 3, x minus 3. Well, I cannot mark anything out, so I know there's no hole in this particular problem. What two numbers, if I was to plug it in, would it make it undefined? That is, x equals negative 3 and x equals 3. Okay, let's graph it. And let's see if it crosses any horizontal asymptotes. Nope, it does not. Alright, so I got one at y equals 0. Then one at x equals negative 3. And x equals 3. Okay, I'm going to pick it, draw my table. Remember, you're going to pick a left value and a right value from each vertical aspect, not horizontal, vertical. So I'm going to pick negative 4, negative 2, 2, 4, and always include 0. Okay? So it goes to my table. Negative 4 is 0.14. Negative 2 is negative 0.6. 2 is negative 1.4. 4 is 1.29. 0 is negative 0.56. Okay, so I'm going to graph that. So I have negative 4, very small. Negative 2. 0, 2, and then 4 was 1.3. Okay. Alright. Now I want to do domain. Start from the left. I'm good till I get to negative 3. Now infinity to negative 3, parentheses, because I don't want to include it. Union, negative 3 to 3, union 3 to infinity. Those are my two trouble spots. Then looking at the range, the y value, start from bottom. Do I hit something on y? Yes. Something's defined. Yes. Something's defined. Yes. You said, Mr. Church, how about at 0? Isn't there a corresponding y value? Yes, so you're good. So my range is all real numbers. All right, number 4. Y equals x squared plus 5x plus 4 all over x squared minus 16. First thing I'm going to do is find my horizontal asymptote. They both have the same degrees. I'm going to divide the coefficient from them. This is a 1, this is a 1. 1 divided by 1 is 1. So y equals 1. Now I'm going to factor this. I know that I cannot plug negative 4 and a 4 into this function because it would make it 0, therefore undefined. So I look here. I can cross this out though. X equals negative 4 is associated with that parentheses. So since I can cross out, since I can remove it, that is known as a hole. There's a hole occurring at x equals negative 4. Then your VA would be x equals 4. So horizontal asymptote at y equals 1. We're going to graph the VA. We're going to come back and graph the whole in a minute. The VA, x equals 4, 1, 2, 3, 4. Alright, now let's make a table. I'm going to pick a value to the left and right of the VA. That would be always include 0, 3, and 5. Now let's graph this to see what's going on. Let's see if it crosses the horizontal. Do you notice it, the horizontal asymptote that y equals 1, it does not cross it. Alright, so now I'm going to look at my table. Zero is negative 0.25, 3 is negative 4, and 5 is 6. Okay, your domain, start from left. You'll have trouble till you get to this right here. So the negative infinity to 4, union 4 to infinity. Domain. Range, start from the bottom, hitting it. I'm hitting it all the way out to get to, is anything hitting at 1? Do I hit anything when I get to 1? No. So my range would be from negative infinity to 1, union 1 to infinity. And since I just did this problem, let's go back to this thing about the range on this problem. There was a mistake right here. Do I hit 0 anywhere on the range? No. So my range in this particular problem would be from negative infinity to 0, union 0 to infinity. I'm sorry, because you are not hitting that 0 at the y. You're jumping over it and going on. So that would be that new range. Sorry about that. So here, we are not hitting 1 on the y anywhere. So that's why we had to make a break there. Alright, and the last one we'll do is number 5 today. Let's look at number 5. Y equals x squared minus 4 over x plus 2. First, horizontal asymptote. The degree is higher in the numerator. Higher in the numerator. So that means none. There's not one. Now, we're going to put VA and whole down. We're going to factor it. Alright, the only thing that cannot be plugged in this function is x equals negative 2, because that would make this undefined. But look here, I can cross this out, so that would be removable. That is a whole, x equals negative 2, and you would not have a vertical asymptote. So you say, guys, well, everything's canceled out. I'm left with x minus 2. So in the end, you're really just graphing a straight line and putting a hole at x equals negative 2. When I said the word hole, I remember something. On this previous problem, x equals negative 4. Sorry about that. There needs to be a hole at x equals negative 4. Where you go to negative 4. 1, 2, 3, 4. And you put a open dot somewhere on that x equals negative 4. I'm so sorry for the confusion there. There should be a hole. Well, therefore, guess what? That changes our domain. I am sorry, guys. I hope you don't confuse you. Alright. So that means I'm going from negative infinity to negative 4 union negative 4 to 4 union 4 to infinity. So I had to take into account this spot and this spot. That's why I had to make a break. So I'm going from negative infinity to negative 4. Then get back on from negative 4 to 4. Get back off, and then from 4 on. Okay? Sorry about that. So, the only thing I worry about here is a hole on this problem. These things cancel out. So all I'm going to do is graph this. That's y equals x negative 2. So I go here, get a few points, go backwards. Now, right here, I'm at x equals negative 2, where that should be a hole. So I'm going to put an open. And that's what my graph would look like. My domain would be negative infinity till I got to here. Union to negative 2 to infinity. My range would be from, because these arrows keep going, negative infinity till I got here, which is negative 4 on my y, union negative 4 to infinity. So to recap for a minute, going back, on this previous number 4, Mr. Esther forgot his hole there. You go to x equals negative 4 and just put a hole where that line's coming through to signal that you know what a hole means. Therefore, that changed my domain here. It went from negative infinity to negative 4, stopped, then negative 4 to 4, and I put parentheses, I did not want to include them, and then 4 on to infinity. Okay. We will continue with the study of rational functions tomorrow.
Speaking of no's, Luke, I can't watch your kids tomorrow. I was given a list today that I have to watch of kids, so I can't watch yours, sorry.
Hurry up tomorrow.